Okay, this is the second video. Still going over exam 1 with Michael. Okay, so I think we're done with 3, so let's go to 4.
Yeah.
By the way, I always tell you, like, if you go back to 3, because I could see that you were thinking there was something different going on here, I increased your score. That's what I'm saying.
Okay.
Show me as much as you can, right? Because I can at
that's
least...
what, like, I wrote that little sentence to the side because I was like, I just don't know what's going on, but I think it's this, but I was like, I don't entirely know.
And that's great, because I think at least I can see what you're thinking like, you know?
Mm-hmm.
Okay, so on number 4, you just made a silly sign mistake. This was -4, f of g of 1. So in other words, you did g of 1 first, which is correct. It should have been, you got -4, but then you put in +4 down here.
Oh, crap.
So
okay.
that's easy, though. Your score went from 0.5 to 0.95 out of 1.
Okay.
5, let's see. Yeah, so in this one, you just missed part B here. This one.
Oh.
So you had 0.75 out of 1 because you missed just 1 out of 4 parts here. So in this one, notice, so when you look for the shift, whenever you add a constant, it goes up,
Okay.
right? So you had it going down.
Yeah.
You did the the horizontal shift correct. You went 1 to the right, which both of these go 1 to the right. So I gave you half credit for that, even though you got this one marked wrong. And you get half credit for that one.
Mm-hmm.
But you got the vertical shift wrong. You went down instead of up. It should have been up.
Okay.
So half of 0.25 is basically 0.13. So I had 0.13. Your score went from 0.75 to 0.88.
Okay.
6 you already had fully correct. 7 on this one this is where if you knew X was in a certain quadrant.
So that was the only thing that was peeving me
Mm-hmm.
was, so I know that it's third quadrant because it's pi to 3 pi over 2.
Mm-hmm.
And like I drew third quadrant. The only thing that was bothering me was it was -12 over 3. So I was like, is that what it?
So you drew what?
Aren't they both negative?
Well, yeah, they are. So in other words, you drew your reference triangle incorrectly. So notice that you should have taken this line you wrote a 5. You should have came up here. See,
that's what. If you look right there, up in the top right of the page, I put the bow tie because that's what I thought it could be.
Oh, that's exactly what it was. You had it wrong as far as where you're.
That's what I did that, and I was like, that's what it could be, but I had no idea.
Mm-hmm.
Yeah.
So if you draw the reference triangle correctly with the line up here, that's a -5 because it's on the negative y-axis.
And that's what. So I put originally, like I knew. Even if it was there, it's in -5 too. And I was like, well, it's -5, but I was like, what is -5 over -13? 5 over 13.
Mm-hmm. But sine is you're right. So in other words, we'll look at here. So 13, the hypotenuse is always positive. You wrote it as negative here.
Oh.
The hypotenuse is always positive.
Okay, I didn't know that. Okay.
Yeah. So what you're trying to label is the other sides as to whether they're positive or negative. The hypotenuse should be thought of as a positive number.
Yeah, I had no idea. Okay. Yep, I had no, because I just thought, oh, well, it's in the third quadrant, it's going way far down, it's negative. Yeah, I never realized that.
Yeah. So
that would have.
So that's your mistake, is that's a positive 13.
Yeah. Okay. Yeah,
Which,
that's fine.
These, basically, I could tell you pretty much knew what you were doing.
Yeah.
So,
yeah, if I knew that, I would have understood it, because I was just like, I know, and that's what was hurting my head was, I was like, well, I figured out all the sides, but I was like, if all sides were negative, cosine of x wouldn't be -12 over 13, it would just be 12 over 13. So I was like, I don't understand why that's -12 over 13. So then I pretty much got to the point where I was like, screw it, I need to push on.
Yeah. And I raised your score from 0.5 to 0.9 because I could tell you pretty much knew what you were doing.
Mm-hmm.
Okay. Let's see. Number 8, I just couldn't give you any increase there. You wrote unit circles, all you wrote, but
yeah.
What you were trying to find, they told you in this problem, sorry, it's right here. So they want you to find the cosine of 7 pi over 12 exactly, because you could plug that into your calculator and get a decimal. But they want you to use this double angle, right? Because pi over 4 plus pi over 3 is 7 pi over 12.
Okay.
So evaluating cosine of 7 pi over 12 is the same thing as evaluating cosine of pi over 4 plus pi over 3. So that's where you have to use this called the double angle identity, where the cosine of A plus B is equal to cosine of A times cosine of B minus sine A sine B.
Okay.
So cosine of pi over 4 plus pi over 3 is cosine pi over 4 times cosine pi over 3. Now you can use the unit circle to find those, right? But you have to know them. So cosine of pi over 4 is root 2 over 2, and cosine of pi over 3 is 1/2.
Okay.
And then minus sine of pi over 4 is sine of pi over 3. So minus sine of pi over 4 is also root 2 over 2, but sine of pi over 3 is root 3 over 2. So the denominator is 4 for both of those. So root 2 times 1 is root 2, and then minus root 2 times root 3 is root 6.
Okay.
So it was just a matter of you have to understand that you need to know this double angle identity and use it. That makes sense?
Yeah.
Okay. So 9, you said later in the notes, but then I went to later in the notes, and you really kind of, I think you were running out of time, or you just wrote no idea. So
the more I looked at 9, the deeper I got in being confused.
So here's the problem with, from having been through Calc 1 before, rules for taking derivatives and stuff already, right? Really, you're kind of, if you were taking Calc 1 the first time, you're just kind of learning that right now. So in this exam, when you're asked to find the slope of the curve, that means you want the derivative. It means you want the slope of the tangent line, which is the derivative. But at this point, we were only supposed to use this derivative definition. Right, so it's the limit as h approaches 0 of f of x plus h minus f of x over h. So I worked that out for you, but you really should try to work some of those out. But I will tell you, you don't really ever have to do this again. And when you get to the final, if you use rules, it's fine with me. Okay, but this is how you have to do it before we know all the rules, which you actually don't get to till section 3.3, which is after this. Okay. And then once you have the slope of the tangent line, you use the point slope formula for the equation of a line. But you have to get the slope of the tangent line first. Okay. So look at that algebra. Make sure you do know how to do it. But I will also say to you, you don't need to do this again. Just use rules from now on. Okay. Right, like you probably know right now the derivative of this guy would be minus 16x, right? Yeah. So minus 16x, you plug in x equals 2, you get minus 32. Boom, you're done. But see how much more work it is here? Yeah, it is. So from now on, though, since you know that derivative is minus 16x, then you plug in x equals 2. You know the slope right at x equals 2 then is minus 32. Then you do your point slope form, which is a simple calculation down here, right? Yeah. And you have it pretty quickly. It's just that in this exam, we didn't have those rules yet, so I just was reminding you how to do it. But I would say to you right now, you don't need to do it like that. You just need to use your rules.
Yeah, that's a lot easier.
Okay. So let's go back here. I'm at 8.5 minutes, so I got to remember that. Okay, so we are on, that was 9, right?
Yeah, that's 13.
Okay, so 10, 11, 12, you got all right, so I didn't look at those that close. So 13 is when we get into the delta stuff, right? Yep. So you did a great job. You got the right graph. You got these numbers in order correctly. A lot of people screw that up because they have a hard time putting negative numbers that don't have the same denominator in order.
Yeah, that's what I just, like, at the top of the page, I just put them all in decimal form so
sure.
I could directly see them.
Yeah, so good. You got the right thing. Now, once you have that, it's really easy because then you say, well, delta is the smallest distance from this middle, this negative 2/3. Okay. So it's the smallest of these two distances that you wrote here, the graph, right? So if I look at the distance between negative 2/3 and negative 4/5, you always take the bigger number minus the smaller number, right? So negative 2/3 minus a negative 4/5 is plus 4/5. So common denominator there is 15. That's 2/15. Okay. You see that? Yeah. Or, I'm not sure that's delta yet. It could be the distance between these two numbers, which is negative 1/2 minus a minus 2/3, or plus 2/3. That comes out to 1/6. But 2/15 is smaller than 1/6. Yeah. And again, if you weren't sure, you just plug them into your calculator. But you had to write it as a fraction here. Okay. So you had to get the right number. If you're doing decimals to see these differences, that's fine, but you got to have the right number as a
Right.
fraction.
Yeah.
Okay. So that's, I really couldn't increase it because you didn't know how to do that
Yeah, that's fine.
delta there.
But honestly, the delta stuff, the more I looked at it, the more my head started to hurt, and I was like, I'm not going to get this right, so I might as well focus on something else.
Yeah, and that's fine. That's absolutely fine. All right, so 14. So you had a score of 0 on this originally, but it's the same idea. I could tell here that you were kind of thinking, oh, okay, he's almost right. It's a distance from 2, but these equations aren't right. It's really, you want to look at 2 minus root 3 and bring the delta over. Delta is possibly 2 minus root 3, or delta is possibly root 5 minus 2 if you bring the 2 over, right? So it's you just have to know which one of these is smaller. Now, I would plug those into my calculator to see, because I don't know either without looking at them. But then it's root 5 minus 2 is the smaller of those two. So I could see that, oh, he's got the right idea here. So I moved your score from 0 to 0.5 on that one. But again, you just didn't have the whole grasp on what delta is. And 15 is the same thing, except you have to run through that whole thing yourself. So you just didn't even work on this problem, I don't think, because I don't think...
Yeah, I mean, I
you answered...
I remember that there was a homework assignment, and I remember I did it once, and I did really well, but that was like step by step going through the notes and the My Math Lab stuff. And when I saw that, I was like, I remember doing that problem, but I was like, I have no idea on this word how to do it. So I was like, and it was like, I think I had like 15 minutes left on the test, and I think it was the very last problem I looked at, and I was like, honestly, I'm just gonna be staring at this for 15 minutes. So I was like, I'm just gonna put something random and turn it in.
Yeah, and that's okay, but try to look at this. I'm sure that problem will come up again, and there's no way to avoid how to do this one.
Okay.
So, it's the absolute value of f of x minus L has to be less than epsilon, right? So then you have to just work that algebra out. It's just algebra is all it is. Okay. But it's algebra that, it's a little intricate. So if algebra is semi-weak-ish, it makes it a little hard. But you just look at this and see if you understand it. And if you don't, we can talk about it. But I think you should really try to work through that. Make sure you understand that. And then again, once you know what the interval is, delta is the minimum distance between the what we're thinking of as the middle, which is 16, and these two numbers. So the minimum distance there is the distance between the 15.3847, because that's 0.6153. But that's the same concept. It's just that you had to get to that. What is that interval through this algebra? Okay. So, it's one of those things like, probably if this, like, I wouldn't kill myself trying to understand this. This is not a big deal in calculus. Okay. This is sort of like calculus wants to run you through some abstract stuff to get you, hey, we're an upper division math class. I want you to see something abstract, so you should really understand how to do this, right? But it's not the end of the world as far as doing well in calculus if this concept evades you, okay?
Okay.
So don't worry too much about it. All right, I got to stop this video because I'm at 13:35. I'm going to stop it.
Fine.